guys doing? Welcome to the very first lesson that we're doing. This is lesson 1 or objective 1.1, which is adding integers with the same sign. So I want to take a second to familiar you guys with the actual worksheet itself. You should see that there's objectives at the top, which say we will add integers with the same sign. Then it talks about a language objective, which we're going to be describing absolute value and talking about that. Then you see bell work, a central question, some vocabulary, and then it goes into independent practice and eventually gets into modeling. Okay, so what I'm going to do with you guys is I'm going to let you look at the worksheet. When I on the videos, my goal is not to do the bell work with you, but rather give you time to do the bell work and then go over it together. So right now, pause the video and take a second to see if you can solve the bell work. So it's asking to fill in the missing numbers and then find the sum and the difference of 1, 2, 3, and 4 within the bell work. So take a second right now and pause the video and complete the bell work. All right, now I'm hoping that you was able to complete that. Let's go over what the answers are in the bell work so we can continue to go into our worksheet. Okay? So what you should have got in your bell work question when you finished is you should have got -10, -5, 0, 5, and 10 for the number line, right? If we realize that zero's in the middle, we should know that positive numbers are to the right and negative numbers are to the left. So as we count those integers, we should have been able to get down to -10. Now the second part of your bell work, which is to add and subtract some numbers, you should have got 261, 389, 290, 1459, and these are our 4 answers to these 4 problems. Okay, now if you had a problem with any of these, maybe you've been carrying or remembering to take away one from the bigger number to the left, something along those lines. We can always review that later if this is a place where you feel weak on, but I want to talk about adding integers with the same sign. Now the numbers we're going to look at today, they're not big like these. They're not big numbers. We're going to look at very small numbers, and I'm going to take time to actually explain to you what an integer is. So first of all, how do you add integers with the same sign? When I say same sign, it could be positive, positive. It could be negative, negatives, right? Positive numbers, you guys seem pretty well. If I ask you what's 5 plus 7, you can use your fingers. You can use a lot of different things to eventually identify what that number is. I really want to focus on negative numbers because I think that's where a lot of us get confused. How do I add 2 negative numbers together and what ends up happening? So I want to show you 2 techniques to use to be able to add these 2 negative numbers today. So first of all, we're going to be talking about integers. What is an integer? An integer is a number, a whole number, either positive or negative. So that means it does not include decimals. It does not include fractions, right? It includes numbers such as 1, 2, 3, 4, 5, 6, 7. All the way, even on the other side of the actual number line, -1, -2, -3, -4, -5, all the way to negative infinity. These are integers, right? Absolute value. Absolute value, according to the vocabulary, is the number, absolute value of a number is its distance from 0. So how far is a number from 0? And we're going to take a second to see if you could actually practice doing that on your own and see if you're capable of being able to solve for the absolute value as well. All right, and then the sum of a number and its additive inverse is 0. Now notice on these vocabulary, since this is our first lesson, the vocabulary falls right into place. I'm not trying to trick you up. They go right one after another, okay? And we're going to look at additive inverse as well, which is pretty much saying a number plus its opposite has to equal 0, okay? So let's look at independent practice 1, which is something I want you to do right now, right? What is the absolute value of -4? 4 minus 4, -9 minus 4. Absolute value of 4, -9 minus 9, and -11. I'm actually going to write these in a couple different ways. One, I'm going to show you what I want you to do for number 1, and I'm going to show you what I want you to do for, I'm going to show you, I'm going to model for you 1 and 2. So that way you can do 3, 4, 5, and 6, okay? So for example, this is asking you the absolute value of -4. Whenever you see these 2 lines, that's saying absolute value. It's saying how far is -4 from 0. And if I just scroll up back on our worksheet, remember we had -5 here, right? And we can assume that -4 is essentially right next to -5, right? -4 is right next to -5, okay? So that being the case, what I would love to do is say, okay, well, if I were to write on this, and let me just write on the screen, I'll put a -4 right here. That's -4. How far is it from 0? Let's count. 1, 2, 3, 4. It is 4 spaces from 0. So when we look at the negative numbers and we're dealing with absolute value, it's really saying how far is that number from 0? And in this case, we would say, okay, well, it is 4 spaces from 0. And that's what we will kind of indicate. Right? We would indicate that this is 4 spaces from 0. Okay? Let me just switch my tool up here. So I would say here the answer for this one is 4. Okay? Because it's 4 spaces from 0, right? Number 2, right? So I'm doing 1 and I'm doing 2. 4 minus 4. Now I don't want you to tell me the answer is 0. That's good. But I actually want us to write it like the additive inverse. What do I mean? We need to know that 2 numbers added together, if they're opposites, equal 0. So what am I indicating here? I'm saying 4 plus its opposite, -4, is what this is. Notice what I did here. And this is very important for our lesson today. Instead of just putting a minus sign, I attached that minus sign to the 4, and then I put a plus between them. So 4 plus, and I grouped that minus with the 4 to make it -4. Okay? So this is how I rewrite 4 minus 4. I write it as 4 plus a -4. And we know that if we were to add these two, it would still equal 0. Right? Let me do one more for you. And then I want you to do 4, 5, and 6. If I were to write this as an additive inverse, I would write -9 plus -4. Our goal is to be able to show that if I did the additive inverse, if I add, and I know that I want to show how to change subtraction to an addition in some sense, right? How do I show this instead of being subtract 4? How can I use this, make this problem an addition problem? How can I make an addition problem? -4 plus a -9 rather, plus -4. And that's the same thing as -9 minus 4. Okay, and you're going to see why we're doing this in a second. Take a second right now, pause the video, and try to complete 4, 5, and 6. Once again, take a second, pause the video, and complete 4, 5, and 6. All right, so I hope you took a second to see if you could solve those. Let's look to see what the answers should have been. You guys should have received, for the answer for number 4, you should have got 4. 4, the absolute value of 4 is 4. Absolute value will always be a positive number, by the way. And then we have 9 minus 9, which is 9 plus a -9. And then finally for number 6, the absolute value of -11 is a positive 11. Once again, absolute value will always be positive. It's never going to be negative, okay? Now let's go on to the modeling that we're going to do today, okay? What I want to do today is this, and let me just scroll up here. Is I want us to add these integers. -5, I want us to add -5 minus 3 and -52 minus 31. Mr. Wolford, what do you mean add? These are subtraction problems. It says -5 minus 3, and it says -52 minus 31. We're going to use the additive inverse to create addition problems. And then I'm going to show you 2 techniques, one called counter with chips, and the other one is called using absolute value. Now, the counter with chips method we're going to do in A, and the absolute value method we're going to do in B, okay? Now, the counter chips method is more of a visual. If you have chips that are different colors, whether you use pennies or you can use coins if you like, a penny and a nickel, or if you want to use actual chips that have 2 sides, so yellow or red, which I do have in class, but because of this year, let's not touch anything. Maybe if you're in class that day, I will let you use your own and I'll wipe them down. But I want to show you a way to do it without chips as well. So when I look at -5 minus 3, the first thing I want to do is turn that into an addition problem. I'm going to say, okay, well, what is -5 minus 3 as an addition problem, right? when I look at that, it's going to become -5 plus -3. Okay? -5 plus -3. Now notice, now you can clearly see, okay, we have two negative numbers that we're adding together. Okay? Now the way I want to show you guys is I want to use the counter chips. In order for me to do that, I want to create a side area as kind of like a key. And I'm going to write that at the top. I'm going to write the word key here to kind of indicate that what I'm about to show you is a key to help you discern what we're going to do. We're going to use open circles. And whenever you see an open circle, when we create open circles, we're going to represent that as a positive number. So it's going to be representing a positive number. Whenever we see a closed circle or a shaded circle, now you can fully shade it if you like. You could just indicate that it was shaded. In that case, we're going to say that this number is going to represent a negative number. Okay? Now, one thing I want you to also know here that's important for this key is that just like any positive and negative, the additive inverse is kind of like if I add one positive plus one negative, this has to equal 0. It has to equal the number 0. Okay? So it's kind of like I'm doing 1 plus -1 equals 0. But I'm showing you that to let you understand that this is important, right? But let's go back to our problem. We have -5 plus -3. What I want to do is I'm going to draw myself 5 negative circles, right? And these circles are indicating that it's negative, right? That's what these circles indicate, that these are negative numbers. And you can fully shade them in, as I am not, but please fully shade them in if you desire to do so. I know some of us may feel like I'm kind of not doing it correctly, so please feel free to fully shade them in. Okay, so we have our -5. Okay, then it says add -3. So are we adding 3 positive numbers like this? Are we adding 3 positive circles? No, we're adding another -3 circles. So I'm going to shade those in as well. Okay, now if you notice here, right, I have -5 plus my -3, and now I need to figure out what they are. Now, do any of these cancel out? Is there an open and a close for me to cancel them out? No, all these are closed circles. Why am I mentioning that? Because if you had an open circle here, you could say, okay, open and a close cancels out, so then you can count all the rest. Now in our situation, we actually don't have any open circles, so let me undo that one. And I can say, okay, let me count them. How many do I have here? I have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, I have 8 of these closed circles, but remember, they represent negative numbers, so I need to include a negative. So my answer for this, -5 plus -3 is -8. Now, if you're better at it and you know another way to do it, that's perfectly fine. However, for the sake of this video and for the sake of this worksheet, I want us to practice other ways to be able to correctly get the right answer. And I want you to be able to practice whenever you see problems like that on the left side of your independent practice worksheet, use this counter chips method. Now, let's go to B. Let's go to B. And for B, I'm going to actually use a different color. Let me use the color blue. We have -52 minus 31. Once again, I'm going to say, okay, let's turn this into an addition problem. Let's turn it into an addition problem. So what does that mean? That means I'm going to say, okay, this is -52 plus -31. -52 plus -31. Okay? So now with this situation, these numbers are really big. Can you make -52 chips and -31 chips? Sure. But I want to show you the absolute value method to be able to do this. So once again, on your independent practice worksheet that you're going to do in a little bit, the left side, you're going to do it as we just did on letter A. And the right side, you're going to do it kind of like I'm doing B. All right, so first of all, I want to figure out what is the absolute value of both of these numbers. What is the absolute value of -52? What is the absolute value of negative 31? Right? What are the absolute value here? So right now, I want you to be aware, we're talking about absolute value. We're talking about inverse, right? The opposite of another number. And right now, we're looking at it saying, okay, well, here, I want to be able to figure out, okay, what is the absolute value of negative 52? You guys should be saying, what is the distance negative 52 is from 0? And that is 52 spaces. What is the distance of negative 31 from 0? And that is 31 spaces. Okay? Now, what are we going to do with these numbers? What I want us to do is after we take the absolute value, we're going to add these two numbers together. We're going to add them together. We're going to say, okay, what is 52 plus 31? What is 52 plus 31? Right? If you do 2 plus 1, you get 3. 5 plus 3, you get 8. Boom. Our answer is 83. Now, do we circle that and say, haha, my answer is 83? No, because we do got to remember that the numbers that we're dealing with are originally negative numbers. So our answer has to be negative. If both of your numbers are negative, your answer is going to be negative. Okay? If you're adding two numbers that are negative, it's going to come out to be a negative number. Okay, that's why we rewrote it. So you can see that there's a negative 52 and there's a negative 31, and you're adding them together, which means your answer also has to be negative. Okay, so this is how we end up doing the chip method. This is how we do the absolute value method. Okay, if you have a question about this, feel free to add a question inside your actual Google Classroom page, or you can always rewind this and watch it again a couple times, and maybe it might click and maybe you might get it. Okay. Take a second. If you need to copy down the notes, pause it, copy down the notes. Great. Let's move on to the next page. Now, this next page obviously is independent practice. It's for you to do. But I do want to start you off to allow you to realize the first thing you need to do on the left, odd numbers, you're going to use counters. You're going to draw me my actual counters here. Draw the counters. On the right, you're going to use absolute value to solve these on the right. And notice, number 6 has 3 numbers there. But remember to write out the actual expression, write it out again, and instead of being subtraction, use addition. Same thing for all of these. 1, 2, 3, 4, 5, 6. Rewrite them as addition problems, and then either show me the actual counters or show me the absolute value. Then I want you to take a second to reflect on your learning. When you're adding two numbers with the same sign, what sign do you use for the sum? What sign do you use for the sum? Right? When you're adding two numbers with the same sign, what sign do you use for the sum? Can you use the same procedure that you use to find the sum of two negative numbers to find the sum of two positive numbers? Can you use the same procedure? Explain. Right? That's a yes or no, and then explain your thoughts. And then I want you to choose any two negative numbers, any two. And I want you to say, just determine, is the sum of these integers less than or greater than the value of either of the integers? Is the sum of them, is it greater or is it less than? Okay? When you choose any two negative integers, okay? Will this be true no matter what integers you choose? Explain, okay? So take a second. I want you to reflect on your learning, complete this, and of course, you do have a homework page to complete as well. Same exact thing, left side, odd numbers, counters, right side, absolute value. I hope this was very helpful, and I hope everybody was able to get something from this lesson. Okay? Feel free to reach out to me on Google Classroom if you have any questions. Until then, look forward to talking to you next time. Bye-bye.